in this YouTube video we will be reformatting the Seagate ST251 hard drive, and as you can see on the screen we've got a drive which has booted or has been attached to a running Cromemco system. It's got 6 heads, 820 cylinders, and so far the number of alternate tracks is set to 0. So this drive is being prepared for sale. Now, as you can probably hear, the drive's quite noisy. I'm probably shouting at this point. Now, having said the fact that the drive is noisy, it's never failed to work and has been in the machine. Well, when it was operating all those years ago, was in our machine room and was always noisy. Anyway, if I had more time, and this is an exercise to the buyer, I would take the drive apart and find the noisy bearings and try and oil them. Maybe there is something to be done in that region. Anyway, the purpose of this video is merely to reformat the drive, and for that I'm going to just write down the fact that it's got 820 cylinders and it's got 6 heads or usable surfaces. And armed with those 2 key points, we're going to do a reformat. So we're going to do a init hard -n. -n says don't look at track 0 of the hard drive, which is where it's getting this information from. So the disk, after formatting, in the 0th track, the first track on the hard drive, it writes a special sector which has this information in it, but we're going to rewrite that. So we're using the -n parameter. Give that a go. And I've spelt it wrong. Okay, we'll try that again, shall we? Init hard -n. Okay, the device that describes the entire drive is STD31. And the surfaces is 6 usable surfaces, and the usable number of cylinders is 820. Non-alternate tracks. So this is the area which I always tend to put at the end of the hard disk, which is a remap area, so that any tracks along the way that are marked faulty we can remap. So it'll become clear once we actually do this, but as long as track 0, the first track, is not faulty, you can remap any of the other usable tracks. So let's say we're going to have 10 alternate tracks. 10? No, we're going to have make it in a number of the usable surfaces multiplier. So we're going to have 18 alternate tracks. Starting from the disk, I'm going to say 0. No, I'm going to say 1. Ah. And starting from a write pre-comp, which is not used, therefore it's set to 820. We are going to initialize tracks this time. So yes, first is 0, last is 819. First head 0, last head 5. Okay, this is going to take a while. Okay, we're nearly done, and we're just finishing the initialisation part, we're going to need to, after we've done this, we're going to need to read every track and every byte from the disk to check whether it's okay. And if it's not okay, we're going to have to update the alternate track table. So, if you want to change the partition table, well, it's actually given the whole disk, partition 0, to have 816 cylinders, and it's leaving the other cylinders for the alternate track, so we don't need to change that. Okay, get focus. We do not need to change that. Alternate track location is going to be, we're going to have it as, so we've got track 0 where the data is going to be stored. We've got track 1 to 819, and we want the last 3 cylinders. So that's 16. So there's 820 tracks, counting from 0. We've got between 1 and 119. Therefore, we want 19, 18. So I'm going to say 17, 817, 817. I don't want to add any alternate tracks at this point in time. No. So it's now finished. If we do a disk info of STD31, we will see the location of the alternate tracks is 817. The first partition runs from 1 to 816, leaving 817, 818, 819 as the place where we can put alternate tracks, and the 0th cylinder is not used. Great, so now all we're going to do is we're going to do a read all minus A of STD31, the whole thing, and look for errors. Again, this will take some time. Now, in the olden days, you'd get errors from the manufacturer printed on the top of the hard drive. And this says on the top of the hard drive, I think it's 366. So it already thinks there's an error on 366 head 2. But let's see what we find. Now what you can do, and I'm not going to do in this video, is you can run read-all multiple times, and you can also run the drive for longer periods until you're satisfied that the errors that are picked up are all the errors that are around. So for example, if you did read-all right now and you find 5 errors, you might do read-all in another hour of running, and in an unlucky situation you might find 5 different errors. So in that situation I would take the first 5 and the second 5 and add them together and say that there were 10 errors. Logically, every time you run read-all you'll get the same errors, unless the disk is literally degrading in front of you, in which case you'll get progressively more errors. But for a working drive, you'd expect to get the same errors, and that would be the errors for the life of the drive. Okay, so just keeping going. Well, it's somewhat of a surprise. There are zero errors on this hard drive. So noisy as it may be, it has zero errors. I am absolutely flabbergasted. That is really, really surprising. I was hoping for at least one error actually, so I could show you how to add an alternate track. But there are no errors. It's just unbelievable. So we've got a drive which has got 820 tracks, or cylinders in total. The first cylinder is used for system stuff, including the disk label. You've then got 3 cylinders at the end, with space for 18 alternate tracks. And then in the middle, if you say the middle, there's only one partition on the disk from starting cylinder 1 to ending cylinder 816. That's shown here. It's called partition 0. It's a whopping 48.9 megabytes, and that is a large amount for disks in a day. So this 50, getting very close to 50 megabytes. Well, it's pretty close to 50 megabytes. So what we'll do, just to finish off, this is a completely optional step, we're going to make a file system on that partition. So let's make a file system on STD0. So this makes a Unix-like file system on STD0. So STD0 is the partition that's referred to here between starting cylinder 1 and up to and including 816. So what's happening now, slightly obscured by the sound of the spinning, is that the hard drive head is seeking all over the place as we write a kind of tree structure for directories and files to be stored. So just like a traditional Unix system, we're writing a set of inodes across the hard drive, and the inode table will store the particulars of every file or directory or pipe or other things that we want to put onto this disk. Well, I just never expected this drive to be completely error-free. That is so unexpected. Still going. Got a lot of writing to do. Okay, we're finished. That's the end of the demonstration, and the drive will shortly be available. Okay, let's shut this guy down in the proper fashion. We're powering off the disk unit.